For this week's CSI CASA Chem 2 video, we're going to be talking about equilibrium constants. So we have an example equation here. So we're just going to walk through how to find not only K sub C, but also K sub P. And that's under the assumption that all three of these molecules are gas. So okay, so the equation for K sub C is the concentration of your products raised each to their own individual coefficient over the concentration of your reactants. Each raised to their coefficients as well. So for K sub C in this equation, get concentration of NH3 over 2, so this, and then over concentration of NH2 to the power of 1 because it has no coefficient, times concentration of hydrogen gas to the power of 3 because of its coefficient. So that's all that K sub C is. It's really easy to find, and then if they give you the concentrations of each of your molecules, you're set. So for K sub P, it's a little more tricky. It's under the assumption, again, that all your reactants and all your products are gas. So you have to make sure that that's true. And you also have to know the temperature that it's happening at. So we're going to assume at this time that this is 20 degrees Celsius. So your K sub P is going to equal K sub C, let's check, times RT to the delta N, where R is your coefficient or your constant, and delta N is the change in moles that you get through the reaction. So for this particular example, we're already going to pull K sub C from our previous that you would have already had to solve or be given. And we'll just pretend that we've substituted that in. The R that you want to use is 0.08206, because that's the one that gives you liters in atmospheres, because you're dealing with pressure. So we're going to do that. And then the really important thing to remember is that temperature has to be in Kelvin. So we're going to convert. So we'll do 273.15 plus 20. And then your delta N, what you're going to do is you're going to take the coefficients from your products and subtract the coefficients of your reactants. So we'll do 2 minus 3 plus 1. So that will give us 2 negative 2. So all in all, you're going to get K sub C like that. So that's all there is for the equilibrium constants. Hopefully that makes sense. And yeah.